Hello, Noya. So I was looking through now your syllabus, and it turns out that in this topic, molecules to metabolism, there are some stuff about drawing monosaccharides, disaccharides, glucose, ribose, and so on, which I didn't realize were in here. I thought they were in this section: carbohydrates and lipids and amino acids or proteins, 2.4. But indeed, you're supposed to start it in 2.1. So there's some things that we haven't covered as a result. For most of it, you can watch some videos online, and they cover it quite well. But here specifically, I'll teach you how to draw ribose and glucose because those are quite tricky, and that's the main thing we'll cover here in this video. So let's start with glucose. Remember, we said glucose was a 6-carbon sugar, right? So if you write every carbohydrate has the empirical formula CH2O, right? Because the carbo stands for carbon, and the hydrate stands for water, hydration, water. So CH2O, you put some parentheses and you put 6 out there since glucose is a 6-carbon sugar, and you multiply this base here times each of these, so you end up with C6H12O6. So what we want to draw is C6H12O6, and here's how you do it, okay? So since we know we're dealing with a 6-carbon sugar, we're going to start with a 6-sided shape, okay, which is a hexagon. You're going to try to draw a hexagon. Hopefully you know how to sketch a hexagon. Let me try and sketch one here. I'll sketch it like this. Okay. So there now we have a basic hexagon. And I've left spaces in here. What are we going to put in there? We're going to put carbons, okay? Because these are carbon rings. These molecules are carbon rings. So let me draw it a different color. We put a C there, a C there, a C there, a C there, a C. And right here at the top, you might want to put a C, but don't. At the top, instead of a C, we're going to put an O. You can think of it as a chimney. We need a chimney at the top. And so that's an O. It's an oxygen, of course. So now we've covered most of the carbons, right? So what we have left is, we've covered most of the carbons. What we have left is to put these waters onto the molecule. So the water, remember, water is H2O. So 2 H's and 1 O. And if you split that up, you can split it like this into an OH and an H, and that's typically how it splits up. So we're going to put on these hydroxides, the OHs, and the hydrogens separately onto this ring. So let's go ahead and do that. Here, this carbon, remember we said carbon takes how many bonds? 4 bonds. So we're going to put like this. Let's just put all the 4 bonds. The specific direction you put them doesn't exactly matter as long as you have 4 bonds. Okay, and here we have 4 bonds as well. Okay, so here we're going to put an OH, and then an H. Okay, and here, since this OH is on top, the next OH is going to be at the bottom because those OHs, they don't like each other, so they repel each other. And since this one is at the bottom, the next one will be at the top. So you have OH there, H. Okay, and then you just alternate like that. Okay, and then here we have an H. And here, instead of putting an OH, remember that we're still missing a carbon, right? Because we only have 1, 2, 3, 4, 5 carbons. So now here, instead of putting an OH directly, first we're going to put a carbon on there. That missing carbon, the one we missed when we put this chimney instead of the carbon. So we put that carbon there. And then on top of that carbon, we will attach the OH. Okay, our last OH is on that carbon. You can think of this as the flag of the house, okay? And so we need to complete this carbon with 2 more bonds because it has just 2 at the moment. So you have there the H and the H, okay? So that is the whole story. It looks a bit scary now, but remember, if we do it step by step, it's quite simple. First, you draw your hexagon, right? Then you place your carbons, and remember to put a chimney at the top there. Then remember that water is made up of OH and H, and you just put them on, OH and H, and then that one is up there, then this one is down, OH and H, this one is on, and so on, and you just alternate them. Okay, so here we have OH down, OH up, OH down, here H, and then here, instead of putting the OH directly, we put our missing carbon, or you can think of this as the flag of the house, and onto that C there, we put the OH. Okay, so you see it's quite simple to draw that glucose. Now, this glucose that I've drawn is only one type of glucose. There are two types of glucose they want you to draw, but don't be scared. They're exactly the same. Well, they're not exactly the same. They have just one small difference between them. So this glucose we drew here, this first OH is on top. Okay, where this first OH is on top, we call that a beta glucose. Okay, beta glucose. You might see it written as D beta glucose, which means delta beta glucose, or no, dextro rotary beta glucose. It doesn't matter. All you need to know is beta glucose. Okay, and then now I'm going to draw alpha glucose, but don't be scared, it's exactly the same. Okay, let me select this. Whoops, how do I select? Lasso select. Okay, I'll duplicate it and I'll just drag it over here to draw now alpha glucose. The only difference with alpha glucose is that first OH, instead of it being on top, it's going to be at the bottom. So here we put the OH and we'll put the H there. Okay, so this is what we call alpha glucose. Now you need a mnemonic to remember it, because alpha sounds like it's on top, right? But no, this alpha is at the bottom. You can think that alpha stands for I'll fall down. Okay, alpha, I'll fall down. So this guy has fallen down. Okay, and this B, you can think of a bee buzzing around in the air. Bzzz, and therefore this OH has to be on top because bees are on top. Okay, so there you have the two types of glucose, beta and alpha glucose. And of course you need to practice those a few times. Now let's look at ribose. Ribose, let's start. So CH2O, and we know it's a 5-carbon sugar, so you have C5H10O5. So what we want to draw is C5H10O5, and therefore we will start with a pentagon. Hopefully you know how to draw a pentagon. It looks a bit like this. Okay, and again we will put our carbons in these spaces, and at the top, instead of putting a carbon, you say, oh, we need a chimney, so you put a chimney, an O there. Okay, and then now we're just going to put our OHs and our H's. First of all, let me put these bonds so I get the nice colors. Okay, remember oxygen only takes 2 bonds, right? You remember from honk. So 1 bond, 2 bonds, 3 bonds, 4 bonds. Okay, hopefully you remember that. Now here the order of the OHs actually doesn't matter so much. They don't care so much, or that is whether OH is on top or at the bottom, but generally we draw it at the top here. So OH here, H, then we alternate it as usual. Okay, so OH, H. So notice that we're alternating, right? So OH is on top, then on the bottom, then on top. Okay, but what I mean by we don't care about the order is there isn't, like in the glucose case, when the OH was on top, we call that beta glucose. When the OH was bottom, we call that alpha glucose, this first OH. But for the ribose, we don't really care about that. We're almost there now. So here we put a hydrogen. Actually, let me erase that. Oops, where's my eraser? So let's put the flag outside there. Put a hydrogen there. And then here, instead of putting your OH directly, you remember, oh, we're missing 1 carbon. Or you can remember, oh, we need a flag. So you put your flag. And then on the flag, you will then put the last OH. Okay. All right. And then you can add your remaining hydrogen so that this carbon will be happy with 4 bonds. So now what we have drawn now is ribose. So this is ribose. Okay, so now you know how to draw ribose and you know how to draw the 2 types of glucose. And those are the 2 hardest parts of this particular chapter. The rest of it you can watch in a different video. Okay, good luck.